आ रहा है ना, अभी दिख रहा है ना? ठीक है, मैं करता हूँ फिर स्टार्ट। Hello students, welcome all. My name is Mayur S. More. I am your chemistry teacher. Okay. Today we're going to start the chapter called mole concept. Okay. This is for JEE Chemistry. And yes, some of you asked the question, Tanishka Kota. Yes, Tanishka, you can. Yes, it is only for JS friend, but yes, you can attend it if you want. There is no problem with it. Okay, indeed, aspirants can also join because you only get the knowledge. Okay, but it is specifically for the JEE aspirants. Okay, so the chapter that we're gonna start today is the mole concept. Okay, this chapter is really important for not only for JEE, for NEET also. Why it is really important? Because this chapter is the basic. Okay, this chapter is the basis of all the chemistry. Whatever chemistry you have, it's the basis of all those chapters. Okay, so let's move ahead now. So this is about our Practically app. Okay, Practically is the only hands-on learning app for 6th and 12th grade student. Okay, you will not find such a good thing in any other app. Okay, you can learn math and science concepts here visually as well as with the 3D models. Okay, you can explore the app. This is the interface which is on your screen right now. Yeah. Hi everyone. Okay, let's start. So the first thing that is our introduction. Okay, matter. Now what is matter? Okay, anything which occupies space and has a mass. Anything which occupies space, okay, space and has a mass, will be called as matter. So anything which occupies space, has a mass and can be felt by our physical senses is called as matter. Okay. Now the broad classification is we will see as we'll progress ahead. Okay. But for the time being, how the matter is classified? Matter is classified as physical and chemical. Okay. The physical classification and chemical classification. What does physical classification states? Physical classification is based on the physical state of matter. Okay, it's based on physical state of matter under all conditions of temperature and pressure. Okay, as far as chemical classification is concerned, chemical classification based on the type of chemical which is involved with it. Okay, so let's see the physical classification. So physically, there are, you already know, the solid, liquid, and gas. These three are basic type. These three are basic classification of matter into the physical category. Okay, we already know what solids are, right? What are solids? Solids are the substances which has a definite shape, definite volume. It has definite shape as well as definite volume, right? What about liquids? What about liquids? For the liquid, you have a definite volume but not definite shape. Liquid will adopt the shape of the container in which you have put it into, right? What about gas? Gas has neither shape nor volume. Okay, examples of solid, you know, the table, then the salt, sugar, these are the examples of solid. Liquid, water, alcohol, oil, these are the liquids. Gas, hydrogen, nitrogen, oxygen, yeah, CO2, we are known with this, right? Then the very new thing that you are going to know here is collider state. What is collider state? Collider state is a substance, I mean, it is that physical particle which has the size of physical particle is 10 raised to 10 angstrom to 2000 angstrom. Now what is mean by angstrom? The 1 angstrom is equal to 10 raised to minus 10 meter. So it's a very small. So if the size of the physical particle, if it lies between 10 angstrom to 2000 angstrom, it will be called as a colloidal state. And you can see the example of colloidal state here. If you want to see the more example here, suppose let's take the let's take an example where you mix sand with water. When you mix sand with water, what do you get here? This is your water, right? And if you observe it closely, you will see the small coarse particles in a sand plus water. Have you observed this? These are the small colloidal particles. These particles, or these are coarse particle actually. Okay, these are coarse particles. These core particles are nothing but they are the colloids. They are the colloids. Okay. Now what is plasma? Plasma is that substance which is present in ionic form. Here, the substance is present in ionic form under extreme conditions. What are the extreme conditions? Extreme condition means under the influence of very high temperature and very high pressure. Here, the temperature is extremely high. Temperature is around 10,000 to 50,000 degrees Celsius, and pressure is also 2 to 3,000 atmosphere. So in that extreme condition, there exists a form which is ionic form. Okay, that is called as plasma. And that plasma, actually, this plasma form, it always, okay, this plasma form, it emits, the light. It emits the beautiful light. So the plasma form is characterized by the emission of a strong light. Okay, that is what the physical classification is all about. Okay, chalo, let's move ahead now. Yeah, so the chemical classification. Look, what is chemical classification? Again, here the classification is based on how different chemicals are arranged. For example, chemical classification broadly is into pure substances and mixture. Now, what is mean by pure substances? Pure substances are the substances which contains only one type of substance. Okay, pure substances are the substances which contains only one type of substance. It contains only one type of substance. That is what the pure substance is all about. What are the examples of pure substances? Examples are like calcium, magnesium, okay, sodium. Now, pure substances, if you take pure substances, okay, if you they have they are composed of only single type of substance. So then mixture. What is mean by mixture? Mixture, again, mixture contains more than one type of substance. Pure substance में क्या होता है? You have only one type of substance. And what is mixture? It contains more than one type of substance. More than one type of substance. Basically, two or more substances, they are mixed together. Okay, now what's the difference between pure substance and mixture? Then in pure substances, it contains only one type of substance. Okay, but in a compound, pure substance is again classified into two categories: elements and compounds. What are elements? These are the elements: calcium, magnesium, sodium. What are elements? And the figure that you are seeing here, this figure is of sulfur. Okay, your elements contains only single substance. Elements contains only single substance, and it cannot break down. It cannot be break down into a simpler substance by any physical or any chemical method. मतलब आप कोई भी physical chemical method लो, you cannot break down element into a simpler substances. Okay, they are the last simpler substances. For example, calcium, magnesium, sodium. Okay, all the metals, non-metals, and all that. Okay, compounds. What is mean by compound? Compounds are pure substances in which there are combination of two or more substances in a fixed ratio. Compounds are the pure substances where there are two or more substances which are combined in a fixed ratio of their weights. Okay, there's a fixed ratio of their weights, and compounds can be classified, or compounds can be break down into simpler substances. For example, the main example of your compound is H2O. Okay. Now we know that if you heat the water too much, you can break down water into hydrogen and oxygen. Okay, you can break it down. Okay, so that is what the compounds are all about. Elements, they cannot be break down into simpler substances. Compounds, they can be break down into simpler substances because compounds are made up of more than one element. Okay, sometimes you have two elements, sometimes you have three, sometimes you have four, depends. Okay, elements, they are only single atoms, they are made up of only single atoms. Okay, now compounds, whatever compounds you take, okay, the main compound will always have a different property than its constituent elements. For example, your H2O is made up of hydrogen and oxygen, right? We knew we knew that hydrogen burns, right? Hydrogen is a combustible gas. Hydrogen can always be burned. And oxygen cannot burn, but oxygen helps in combustion, right? Oxygen helps in combustion and hydrogen burns. So if you combine them together, you get the water. Water does neither, right? Water is not combustible and it does not helps in combustion also. In fact, in fact, water is used to extinguish the combustion, right? So isn't that amazing, right? You can take one more example. I can give you one more example for that matter. Let's take an example of NaCl, right? We all know NaCl, what NaCl is, right? NaCl is your table salt, right? We consume it every day. We consume NaCl every day, right? Now your NaCl is made from sodium and chlorine. Your NaCl is made from sodium and chlorine. Now if you take sodium, if you put sodium into water, it will catch a fire. Sodium, when comes in contact with water, it catches a fire. Chlorine. Chlorine, if you inhale the chlorine, you may die. If you inhale the chlorine, you may die because chlorine is extremely poisonous gas. Chlorine is very poisonous. Sodium is also, if you touch the sodium, it might burn your fingers. Okay. But if you combine them together, if you combine sodium and chlorine together, you get what? You get salt, NaCl. And we know that NaCl does not do this. NaCl, when put in water, does not catch a fire. NaCl, NaCl is not poisonous either. NaCl is good for our health, right? So that's how the compounds are. Now mixture. As I told you earlier, mixture contain more than two or more kind of substances. They are mixed together in any ratio. So that's the difference between compound and mixture. In compound, you have a fixed ratio. For example, in H2O, we will see that very shortly. H2O, you have 2 grams of hydrogen and 16 grams of oxygen, right? So if you take the ratio of hydrogen to oxygen, it becomes 2 as to 16, which is equal to 1 as to 8. Okay, this is H2O. Hydrogen is 2, oxygen is 16. So if you simplify the ratio, what you get? You get 1 as to 8. So this is the ratio you have of the elements. Okay. If you take the ratio, if you take the mixture, in mixture, the ratio, this ratio of two substances is not fixed. You can have any ratio. Okay. Now this mixture is classified into two categories again, homogeneous and heterogeneous. What is mean by homogeneous mixture? In homogeneous mixture, two or more substances, they are mixed together in a uniform way. Two or more substances, they are mixed together in a uniform way. For example, salt plus water is a homogeneous mixture. Sugar plus water is a homogeneous mixture. Alcohol plus water is a homogeneous mixture. The one you are seeing on your screen right now is a tea. Tea is a homogeneous mixture, right? Then what is mean by heterogeneous mixture? Heterogeneous mixture is the mixture is a mixture which is not in a uniform way. Matlab, two phases, they are not completely miscible, because homo means what? Homo means same. Hetero means what? Different. So heterogeneous is what? Oil plus water is a heterogeneous mixture. Sand plus water is a heterogeneous mixture. The one you are seeing here, that the cornflakes plus water, cornflakes plus milk, that is also a heterogeneous mixture. Okay, so these are some of the examples. These are some of the examples of homogeneous and heterogeneous mixtures. Okay, let's move ahead now. Now, as I told you, pure substances, we had seen the definition of pure substances already, right? In pure substances, you have only one type of atom. For example, pure substance have been classified into elements and the compounds. What are the elements? Elements are further classified into metals, non-metals, and the metalloids. What are the metals? We know what metals are, right? Metals are, they are malleable, ductile, lustrous, right? Lustrous means what? They are the shiny. What are the examples of metal? Examples of metal: copper, iron, gold, silver, platinum, nickel, zinc. All of these are metals. We already know what metals are, right? Non-metal. What are non-metals? There are only two types of substance basically in the periodic table, either metals or the non-metal. What are the non-metals? Non-metals are like your carbon, boron, nitrogen. I won't say boron, but carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, these are your non-metals. Then what are your metalloids, and what is mean by metalloids? See, there are some elements whose properties lies between metals and non-metal. There are some elements whose property lies between metals and non-metal. They can show the properties of both. Such elements are called as metalloids. What are example? You can see on the screen: boron, silicon, germanium, है ना, arsenic. Okay, you can continue with the class. ठीक है. So what I was saying, that in nuclear reaction are the only exception to this. Okay. Now the next law. Now next law is law of constant or definite proportion. Now what is law of constant or definite proportion? Now see, this law was given by, okay, what is this law? This law says that all chemical compounds are found to have constant composition irrespective of their method of preparation. That means you can prepare a given compound in whatever way, okay? You can have any method of preparation or any source. Okay, all chemical compounds are found to have constant composition irrespective of their method of preparation or their source. That means if you have a water, let's take example of a water only. You can see here, in water, hydrogen and oxygen, they are combined in the ratio 2:1. That means you have, see, if you take the water, the hydrogen is 2 grams, right? Oxygen is 16 grams, right? So if you take the ratio of 2:16, you will get the simplified ratio as 1:8. So you take water from any sources that you think. You take water from any sources. You can take water from river, ocean, lake. Okay, you can take water from rain. You can take the water from gutter. You can take water from any source. whatever source you have, the ratio of the atoms of the water by mass will always be 1:8. Okay, it is like in H2O you have 2 grams of hydrogen and 16 grams of oxygen. So if you take the ratio 2:16 is equal to 1:8. Okay, it is just like that. Let's take another example. Suppose if you have methane. If you take methane, CH4, the atomic mass of carbon is how much? 12. And there are 4 hydrogen, so mass is 4. So if you take the ratio, it becomes 3:1. So you can prepare methane by any method. You can obtain the methane by any source. The ratio of the atoms, the ratio of the weights of the atoms of methane, which is carbon and hydrogen, will always be 3:1. It will always be that way. Okay? So that's what is called as law of constant or definite proportion. Okay, let's solve one numerical based on this. See, you can see here the numerical is 1.80 grams 1.80 grams of certain metal burnt, okay, burnt in oxygen to give 3 grams of its oxide, okay, and 1.50 grams of same metal heated in steam to give 250 grams of its oxide. Show that these results illustrate the law of constant proportion. Let's take the first. You have a 3 grams of oxide, okay, which contain 1.80 grams of metal. That means 3 grams of oxide minus 1.80 grams of metal, it would give you what? It would give you 1.20 grams of oxygen, right? So if you take the ratio, of metal to oxygen, you will have 1.80 grams of metal to 1.20 grams of oxygen. Grams cancel, 0 get cancelled. You get 1.8 divided by 1.2 is equal to what? Is equal to 1.5:1. The ratio between metal and oxygen is 1.5:1, right? That is what the ratio you have here. Let's take another example, this one. Here 1.50 grams of same metal heated with steam to give 250 grams of its oxide. So here you can have 250 grams oxide minus 1.50 grams of oxygen. You would get what? You would get 1 gram of oxygen. So again, if you take the ratio of metal to oxygen, you will again have 1.5 divided by 1. So ratio again is 1.5:1. See, so here also you have ratio of 1.5:1. Here also you have ratio of 1.5:1. Hence the law of constant or definite proportion is proved. Okay, sure. Let's move ahead now. See, the next law is law of multiple proportion. So what does law of multiple proportion states? See, law of multiple proportion, it was given by Dalton. Okay, these were the scientists who initially worked very hard on these laws of combination. In them, Anthony Lavoisier was there, Dalton was there. Okay, so what does this law states is that when one element combines with other elements, and one element combines with other elements to form two or more different compounds, when one element combines with other element to form two or more different compounds, the mass of one element which combines with the constant mass of the other bear a simple ratio to one another. Now, this may appears to be a quite complicated law when you hear it. Okay, let's make it simpler by taking example. See, carbon when combines with oxygen, it gives you two kinds of oxide. One is CO, carbon monoxide. Another is CO2, that is your carbon dioxide. So if you take the carbon, okay, carbon, it combines with oxygen, half O2, that is also gas, it gives you CO. So if you take the mass of it, you can have 12 grams of carbon and you will have here how much? 16 grams of oxygen. Okay, that gave you CO. Let's take next example. Here carbon, again carbon is 12 grams, but this time it reacts with the complete mole of oxygen O2 to give you CO2. So here the oxygen is how much? 32 grams, right? The atomic mass of single oxygen is 16 grams. So O2 is 32 grams. So you can see here what I was saying is that the mass of one element, now that one element here is oxygen, the mass of one element which combines with constant mass of the other. What is constant mass? That is carbon. That is equal to how much? 12 grams. The mass of one element which combines with the constant mass of the other bear a simple ratio to one another. तो इसका मतलब क्या है? What does this mean? Is that carbon is the element which combines with the constant mass of the carbon. Sorry, oxygen is the element which combines with the constant mass of the carbon here. So this mass is how much? 16, 32. So if you take them 16 as to 32, that is equal to 1 as to 2. It's a simple whole ratio, 1 as to 2. Okay, that's what the law of multiple proportion is all about. Let's take another example. See, hydrogen reacts with half mole of oxygen. I'll write here rather. See, hydrogen reacts with half mole of oxygen to give you H2. Now hydrogen is how much here? 2 grams. How much is the oxygen? 16 grams. Same hydrogen reacts with complete O2, complete mole of O2 to give you H2O2. Yeah, here you do not have a 2. Okay, simple hydrogen. So again, hydrogen is 2 grams, oxygen is 32 grams. You get the same compound. You get H2O2 here, you get water here. This is hydrogen peroxide, that is hydrogen. So 2 grams of hydrogen is same here, right? It is same. And look at this ratio again. This ratio is 16 as to 32. If you make it simple, it becomes 1 as to 2. That's how the law of multiple proportion. That means the element which combines with the constant mass of the other element. So the element which has a constant mass, you don't have to take the ratio of its weight. You have to take the ratio of weight of the other element. You have to take the ratio of the weight of the other element whose mass is changing. Because oxygen's mass is changing. Here it is 16, here it is 32. Same thing goes here also. So that is what the law of multiple proportion is all about. Okay. So let's move ahead. The next is law of reciprocal proportion. Now, what is mean by law of reciprocal proportion? The law of equivalent weight. See, this law is a bit complicated now. See, it was given by Richter. Okay, what is this law? This law states that the ratio of weights of two elements A and B, which combines separately with the fixed weight of the third element, which is C, is either the same or simple ratio of the weights in which A and B combine directly. That means you can look here, the ratio of methane. In methane you have 12:4, the ratio is 3:1. Okay. Let's take carbon here, hydrogen here. This is the arrow combining them together. Okay. Now oxygen. Now your oxygen and carbon combines to give us CO2, right? The carbon's atomic mass is 12. There are two oxygens, so 32. The ratio is how much? If you divide both of them by 4, you get 3:8. Okay. Similarly, hydrogen, oxygen, they combines to give you H2O. H2O you have ratio 2:2, 2:16, which is 1:8. So 3:8, 1:8 is common. So what you got here is 3:1. This ratio of 3:1 is equal to 3:1 ratio of carbon and hydrogen. That is what this law is saying. That means the ratio of weights of two elements. Which are those two elements? A and B. The carbon is A, hydrogen is B. Okay. The ratio of weights of two elements A and B, which combines separately with the fixed weight of the third element. What is that third element? The C is your third element, that is oxygen here. And what is the fixed mass of oxygen here? Is 32 grams. Okay. So you can take 32, you can 16 grams, whatever. Here hydrogen is single, that's why two hydrogen. Okay. The fixed mass or weight of the third element C is either the same or simple ratio. So that simple ratio is same. You can see here the ratio between carbon and hydrogen is 3:1. Okay. Then carbon was combined with oxygen, that gave us CO2 12:32. The ratio was 3:8. Okay. So carbon separately combined with oxygen, that gave us ratio 3:8. Then hydrogen separately combined with oxygen, that gave us the ratio 2:16, 1:8. Okay. If you take the ratio of 3:8 as to 1:8, you get the ratio 3:1. If you take the ratio of these two, that means 3 divided by 8 into 8 divided by 1. 8 gets cancelled. What we get is 3:1. That's what the law of reciprocal proportion is all about. Yes, Sajid, you asked something? What about carbon monoxide? Yes, Sajid, you're right. It is 3:2 because it should be a whole number ratio, right? And what about carbon monoxide? Means CO. See, carbon generally combines with oxygen to give us CO2. Okay, it does not give us CO that easily. You can get a CO under certain conditions only. Okay, Sajid, generally you get CO2 only. So, chalo, that's it for this law of reciprocal proportion, which is also called as law of equivalent weight. Okay, chalo, let's move ahead. Let's take the numerical based on reciprocal law. Let's take the numerical based on reciprocal law. Okay, what is your numerical? The numerical is ammonia contains 82.35% of nitrogen and 17.65% of hydrogen, comma, water contains 88.90% of oxygen and 11.12% of hydrogen. So if you take this, that look, 17, let's solve this. Okay, all this data we need to show that this data illustrates the law of reciprocal proportion. Let's take it one by one. Let's take the hydrogen and nitrogen. See, 17, let's convert this into grams. Okay, ammonia contains 82.35%, that means 17.65 grams of hydrogen requires 82.35 grams of nitrogen. Therefore, yes, Meenakshi, you have some doubt? Therefore, 1 gram of hydrogen would require, so 1 gram of hydrogen would require, so if you combine this together, you get would require is equal to 1 into 82.35 grams divided by 17.65 grams. Okay, so if you solve this, you would get 4.67 grams of a nitrogen. Okay, let's take the next. The water contains 88.90% of oxygen and 11.10% of the hydrogen. Now here, if you solve this again, see 11.10 grams of hydrogen requires 88.90 grams of oxygen. So therefore 1 gram of hydrogen would require how much? 1 into 88.90 divided by 11.10 is equal to 8.01 grams. Okay, so if you take the ratio of weights here, if you take the ratio of weights of nitrogen and oxygen here, okay, ratio nitrogen as to oxygen or oxygen as to nitrogen, whatever. Let's take oxygen upon nitrogen. So this is 8.01 divided by 4.67. Okay, this ratio comes to be 1 as to 1.70. Okay, this ratio comes out to be 1 as to 1.70. Okay, now let's take next. Now nitrogen trioxide contains 63.35 grams of oxygen and 36.85 grams of nitrogen. Okay, let's take their ratio. If you try to see their ratio, oxygen is 63.15 as to 36.85. Okay, if you solve this 63.15 divided by 36.85, you will get the ratio 1 as to 1.7. So here also the ratio came out to be 1 as to 1.17. Here also it came out to be 1 as to 1.17. That's how the law of reciprocal proportion is proved. That's how you can prove the law of reciprocal proportion. Okay. So we can move ahead now. So that was the numerical based on this. Yeah. Okay. So let's move ahead. Now the last part, that is relative atomic mass. Now what is mean by relative atomic mass? See, if you want to measure the mass of atoms, how would you measure it? It is really difficult, because suppose if you go to the market and if you ask a sabji vendor that uncle, please give me a 1 kg of tomato or potato. So if he hands over a small number of potato or tomato, it won't be good, right? You may get less amount of the food that you want. So what you need to do, you need to have some reference for that 1 kg of aloo or tomato. The same thing goes with the atoms also. Okay, how does relative atomic mass is concerned? See, it is expressed as mass of one atom with respect to some fixed standard. It is expressed as mass of one atom with respect to a fixed standard, and fixed standard could be anything. Okay, Dalton initially used a fixed standard as hydrogen. Hydrogen was used as a fixed standard initially. Okay, later on oxygen was started using as a standard. Okay, Meenakshi, you have a doubt, right? Element. Meenakshi, look, element is the purest form of any atom. Okay, if you take any element and if you try to purify it, you cannot convert it into simpler form. That means elements are the purest form of any atom. For example, if you take a sulfur, okay, if you try to break it down, sulfur, further, you will not get any simpler substance. You will get sulfur only. Its physical form would only change. Okay, but element would still remain as sulfur only. But if you take the compound, for example, CO2, you can break down CO2 into carbon and oxygen. If you take a compound like H2S, you can break down H2S into hydrogen and the sulfur. Okay, so you can break it down. That's a compound. For as far as elements are concerned, they are the ultimate smallest form of any substance. Okay, Meenakshi, elements are the ultimate smallest form of any substance, which cannot be break down further by any simpler means. Okay, chalo. So the last part of our lecture is relative atomic mass. Now relative atomic mass is what? As I told you, Dalton initially used hydrogen as a standard. Okay, later on oxygen was started using as a standard. Okay, but people found some of the flaws with that. There were many flaws with that. Okay, so that's how it was. Eventually, people eventually stopped using them as a standard. Then recently in 1961, people started using the new method. They started using carbon as a standard. Started using carbon as a standard, where the C12, the C12 isotope of a carbon is used as a standard. Why? Because it is a very stable isotope. C12 isotope is very stable. Okay, so how would you define the atomic mass unit? The atomic mass unit is equal to 1/12 of the mass of one atom of C12 isotope. That means if you take any mass, if you take one atom, single atom of carbon's 12 isotope, C12 जो है, you need to take the single atom of that. Okay, that single atom of C12, you have to divide that by 12. Okay, and that will be equal to your 1 AMU. AMU means what? Atomic mass unit. AMU is called as atomic mass unit. And what is the value of 1 AMU? 1 AMU is equal to 1.66 into 10 raised to minus 27 kilogram. Okay? If you convert it into kilogram, you would get this. And in the grams, 1.66 into 10 raised to minus 24 grams. Okay, that is what the 1 AMU is all about. Okay, so this is a standard people nowadays uses for the measuring of any other substance. Okay, that is what the relative atomic mass is all about. Okay, so now if you have any doubt, you can ask me in the chat section. Thank you, Sajid. Thank you very much. See, if you have any doubt, you can ask me, Minakshi, Donuru, Sajid. Yes, Penta, you can ask me if you have any doubt. Okay, chalo, very good. Then I'll finish it off. Chalo. Thank you very much. Chalo. Thank you.